Hello. One of the mysterious inequalities of quantum physics is the Heisenberg's uncertainty principle. It looks like this. Delta P delta x is greater or equal to reduced Planck's constant divided by 2. Where delta P is the change in momentum of a particle. Delta x is the change in position of a particle. Popular explanation sounds like this: it is not possible to accurately measure the position and momentum of a particle at the same time. The more accurately you measure particle's position, the less accurately you're able to measure its momentum, and vice versa. This formula actually describes standard deviation, and standard deviation is telling us about error in measurement, so the real formula would look like this. Delta P delta x is greater or equal to reduced Planck's constant. This is one of the base principles of quantum mechanics that does not need any farther explanation. This is the final point. I'm not physicist, not even scientist, I have nothing to lose, so I'll try to provide a possible deeper explanation. Indeed, how not being able to measure something can be an answer to a global why question? I would say it's not even a law, it's only a limitation of measurement. As you probably remember, all videos on this channel are based on the same basic idea that our universe is a huge discrete robot and movement consists of mutually exclusive events. In one of my previous videos I assumed that each elementary particle is actually a discrete machine that consists of discrete pieces with energy equal to reduced Planck's constant. E equals reduced Planck's constant multiplied by W. W according to that assumption is not frequency but the amount of discrete pieces in the particle. Each discrete piece stores one of 6 possible directions in space, and these pieces navigate all the particle one by one in infinite loop. The link to that video is in the upper right corner now. Please review to understand the assumption better. We can also call those particles colonies of primitive beings, discrete machines that move through space as a single elementary particle. These primitive beings navigate the colony one by one in infinite loop. Each being, quantum of energy, does not belong to a colony, but rather moves with the colony. So how interaction could happen in such discrete world? I see only one possible way: particle could exchange those discrete pieces. Or we could also say that the primitive beings could leave their current particle and join another one when those particles are close enough to each other. What would happen in this case? Let's assume that we had 2 particles. These particles have energies. E1 equals reduced Planck's constant multiplied by W1. E2 equals reduced Planck's constant multiplied by W2. One discrete piece could move from second particle to first particle and we would get E1 equals reduced Planck's constant multiplied by W1 plus 1. E2 equals reduced Planck's constant multiplied by W2 minus 1. And what do we get? Energy of each particle changes, momentum changes, either increases or decreases, direction of each particle movement could change too. The change of E1, delta E1 equals reduced Planck's constant multiplied by W1 plus 1 minus reduced Planck's constant multiplied by W1 equals reduced Planck's constant. So the result of any interaction will be energy update for each particle. The delta will be equal to the reduced Planck's constant, and that will also cause the particle momentum or position update. So how we can explain the Heisenberg uncertainty principle? To measure a particle you need to interact with it. The more you interact with the particle, the more discrete pieces you pass to it, or the more discrete pieces you extract from it. Each piece has one of 6 possible movement direction in space, and even if you use a photon that mainly consists of 3 directions, you cannot know which exactly kind of discrete pieces, with which directions, will be passed to a particle. Or which exactly kind of discrete pieces, with which directions, particle will pass to the photon or photons. In other words, the more you measure the particle, the more you unpredictably update it. So, by measuring momentum of a particle, we update the particle and make its location unpredictable, but we do that ourselves, not some mysterious principle do that for us. By measuring location of a particle we update the particle and make its momentum unpredictable, but we do that ourselves, not some mysterious principle do that for us. The interesting thing is that quantum mechanics has a separate principle, the observer effect, which states exactly that, measurement updates the particle. Well, it states not only that, but updating the particle is definitely a part of that principle. So physicists know that observation changes the particle but still prefer to separate Heisenberg uncertainty principle and observer effect as if they are unrelated. Why? I have no any idea. As you can see, for this imagined discrete world of robots they have much common. But there is also some difference. In short, it's the same difference as the difference between random event and the central limit theorem or expected value. The observer effect itself I will review in a separate video. Also I will review other mysteries of quantum physics, the Bell's inequalities, the double slits experiment and others. As for Bell's inequalities I can say in short that they are not applicable because of the observer effect. I perfectly understand that a process of replacing mysterious beautiful science with ugly discrete machines, which are just playing their primitive games and are switching their particles is not something that everybody would love. We love miracles and complexity. We love Santa Claus, Star Wars, Big Bang and other mysteries. They give us positive emotions and happiness. But as I told before, I don't have other universe for you. Sorry. The world does not have to be beautiful and complex just so you could feel happy about it. It might appear that there are no any miracles down there, in quantum mechanics. But instead all the miracles we see around us were constructed by those ugly primitive discrete creatures, who were playing their primitive games. So let's play the game. Thank you for your attention.